multiplied by what will give us 1? It will be 1/2. 2 multiplied by 1 over 2 will give us 1. And what multiplied by 6 will give us 1? 1 over 6. What are these two numbers called? Each of them is a reciprocal of the respective numbers. 1/2 is the reciprocal of 2 and 1 over 6 is a reciprocal of 6. Does a matrix have a reciprocal? Let's say we have matrix A. In matrices, the identity matrix represents 1 or unity. So we can ask A multiplied by what will give us I or the identity matrix? Yes, what can we have here such that the product of these two matrices will give us the identity matrix? Instead of writing 1 over A, we write something called A inverse. Yes, this is the inverse of matrix A with -1 as the superscript. And A times A inverse will give us the identity matrix. And what multiplied by A will give us the identity matrix? Again, it's A inverse. A inverse times A will give us the identity matrix. This is the concept of an inverse of a matrix. Its product with A will give us the identity matrix. Let's look at an example on a new page. We are given matrix A. It's a 2 by 2 matrix. And for this matrix A, we are given A inverse. It equals this. Now we need to check if their product gives us the identity matrix. On the left side, we multiply A with A inverse. And on the right, we multiply A inverse with A. Remember that matrices are non-commutative. A times B may or may not equal B times A. We need to verify both these products. This is matrix A multiplied by A inverse, and this is A inverse multiplied by matrix A. We start off by finding the product on the left. What will be the 1/1th element? It will equal the product of the first row with the first column. 2 times 1 plus 1 times -1. 2 minus 1. For the 1/2th element, we multiply the first row with the second column. 2 times -1 plus 1 times 2. We get -2 plus 2. For the 2/1th element, we multiply the second row with the first column. 1 multiplied by 1 plus 1 multiplied by -1. That will give us 1 minus 1. And for the last element, we multiply the second row with the second column. 1 multiplied by -1 plus 1 multiplied by 2. -1 plus 2. Now we just calculate the 4 elements. 2 minus 1 is 1. -2 plus 2 gives us 0. 1 minus 1 is 0. And -1 plus 2 equals 1. Yes, we get an identity matrix. A times A inverse gives us the identity matrix. What about this product? Why don't you pause the video and find out what this product gives us? This is what we get. This is the first row multiplied with the first column. This is the first row multiplied by the second column. Second times first and second times second. What do we get after solving each? 2 minus 1 is 1. 1 minus 1 is 0. -2 plus 2 is 0. And -1 plus 2 is 1. Clearly an identity matrix again. Both products give us the identity matrix. Wait, hold on. Finding the reciprocals of numbers was easy, but how do we find the inverse of a matrix? We will cover that in the next few lessons. Given a 2 by 2 matrix A, do you remember how we found its inverse? Given A, how did we find A inverse? We had used column and row operations. Yes, elementary operations. Do you remember how we'd solved it? We first write the matrix A as I times A, where I is the identity matrix or the unit matrix. And then we perform row operations on matrix A to reduce it to the identity matrix. Performing the same row operations on I, reduces it to A inverse. And we keep this A as is. That's how we get A inverse using row operations. Similarly, we get A inverse using column operations like this. A is reduced to I, and this I is reduced to A inverse. Now if you remember, this technique was very tedious and long. Is there a better and a quicker way to solve for the inverse of a matrix? Yes, there is. Let's look at it on a new page. Let's find the inverse of A in a different way. There's a very simple formula to find the inverse of a matrix. It is equal to 1 over determinant of A multiplied by the adjoint of A. This is the formula of A inverse. 1 over determinant of A multiplied by the adjoint of A. So all we really need of the inverse is the determinant and the adjoint of the matrix. No row or column operations needed. But there is one important condition here, and it's intuitive. The determinant of A cannot be equal to 0. In fancy words, we can say that matrix A has to be a non-singular. That's because the denominator cannot be equal to 0. So before finding the adjoint, let's first find the determinant of A. What will be the determinant? It will be 2 times 3 minus 5 times 1. 6 minus 5 is 1. The determinant of A is non-zero. Matrix A is non-singular. So this formula will work. Now we need to find the adjoint of A. Do you remember the shortcut to find the adjoint of a 2 by 2 matrix? We interchange these two and change the sign of these two. So what will be the adjoint here? 2, 3 will be written as 3, 2. 5 will change to minus 5 and 1 will change to minus 1. Interchange and change the sign. Now that we have both, we move on to finding A inverse. The determinant of A is 1. So 1 over determinant of A will be 1 over 1. We write the adjoint of A as is. Solving this will give us the inverse of A. Now 1 over 1 is 1. Multiplying the scalar 1 with every element will keep the elements unchanged. So A inverse will equal this matrix. To verify the answer, try multiplying matrix A with this one and you should get the identity matrix. I feel this was clearly easier as compared to the row or column operations. In the next part of the video, we will find the inverse of a 3 by 3 matrix using this formula. How do we find the inverse of matrix A here? It's a 3 by 3 matrix this time. The formula for A inverse that we saw in the previous lesson is valid for all square matrices. It's equal to 1 over the determinant of A multiplied by the adjoint of A. No elementary operations needed. The condition states that the determinant of A must not be equal to 0. That's because the denominator cannot be equal to 0. If the determinant of A is 0, then we can say that the inverse of matrix A does not exist. So that's the first thing we should do. We find the determinant of A. We can have the first row as the reference. Because we've already solved innumerable determinant problems, let's go through this quickly. The element 2 will be multiplied with this determinant to get this. 2 multiplied with 1 times 0 minus 2 times 1. The next element is minus 1. We get this. Minus because we are multiplying this product with minus 1 raised to 1 plus 2. The last element for the first row is 0. Because it's 0, it doesn't matter what it's multiplied with. The product will always be 0. This will be the value of the determinant. This part in the brackets will equal 0 minus 2, which equals minus 2. 2 times minus 2 will equal minus 4. What about the second product? Inside the brackets, we have 0 minus 2, which equals minus 2. 1 times minus 2 is minus 2, and this product is 0. Minus 4 minus 2 will equal minus 6. We have the determinant now. It's minus 6. As it's not equal to 0, we can say that it's non-singular. the inverse of this matrix exists. So we can move on to finding the adjoint of A now. To find the adjoint, we first find the matrix of cofactors of each of the elements and then find the transpose of that matrix. So let's find the cofactors of each of the elements now. The first element is 2. Its cofactor will equal -1 raised to 1 plus 1 times its minor. Its minor is the determinant of what's left after excluding its row and column. So the cofactor will equal 1 multiplied by 0 minus 2. Minus 2. The cofactor of this 2 is -2. Now we come to the cofactor of -1. It will equal -1 raised to 1 plus 2 times 0 times 0 minus 2 times 1. -1 times -2 is 2. Similarly, we get the cofactor of 0 as -1. Now please pause the video, take your time and solve for the remaining 6 cofactors. These are the 6 remaining cofactors. This transpose will give us the adjoint of matrix A. To find the transpose, we interchange the rows and the columns. The first row will become the first column, -2, 2, -1. The second row will be the second column, 0, 0, -3. And lastly, the third row will become the third column, -2, -4, 2. Now we have the adjoint as well. And because we have both, we can find A inverse now. Let's write it here. 1 over determinant of A will be 1 over -6. We multiply this with the adjoint of A. What will this be equal to? This is the adjoint. To get this, we multiply this scalar with each element of the adjoint. 1 over -6 times -2 will equal 1 over 3. 1 over -6 times 0 will equal 0. 1 over -6 times -2 will equal 1 over 3 again. And like always, I want you to find the remaining 6 elements. Remember, we need to multiply each of the elements with this scalar. These are the 6 elements you should have got. This is A inverse. We found it using this formula. So this was pretty long, but still faster than using an elementary operation. Remember the formula. A inverse is equal to 1 over the determinant of A times the adjoint of A.